be gone this Thursday.
Okay, just remind me tomorrow and I'll make sure you get everything you need ahead of time.
10-4.
Okay, so we left
Alrighty
off
then.
yesterday talking about scientific notation, converting from one form from scientific notation to standard notation or decimal notation. If I have something like 2.9 times 10 to the negative 7, the 2.9 stays. The 10 to the negative 7 tells us what place value we're dealing with. Being a negative power, that means it's a small place value. So we're going to make this number smaller by moving the decimal point 7 places. So we start there, we're going to go 1. Now to keep going, we have to add zeros. So we go 2, 3,
3, 4, 5, 6, 7.
says point 0.0000029 is what that number comes out to be. Or we might have had an 8.4 times 10 to the 8th. So same thing, we start out with the 8.4. The 10 to the 8th being a positive power tells us that this is a large number. So we're going to make this larger by moving the decimal point 8 spots. So move one spot again. We have to add zeros to go 2, 3, 4, 5, 6, 7, and 8. So that is 8 billion, or sorry,
8.
840 million.
Yep.
What that comes out to be. So then the flip side of that is going from standard notation into the scientific notation. If I have a number like 600 and let's just go 65 million. To change that into scientific notation, we first find the first non-zero digit. Here that'll be the 6. And we're going to write the number with moving the decimal point to after that first non-zero digit, and any trailing zeros, now by trailing zeros I mean zeros at the end of the number like these, can be dropped. But now the decimal point has to move. It starts out here in this number. Remember, if the decimal point isn't written, it's at the end of the number. And it moves 1, 2, 3, 4, 5, 6, 7 spots. 6.5 times 10 to the 7th. Or we might have 0.00038. So again, we identify the first non-zero digit. That's the 3. We're going to put our decimal point after that, 3.8, and rewrite the rest of the number that follows that. And then we got to figure out our place value. So this will be times 10 to the decimal point started here, and it went 1, 2, 3, 4, 5 spots. Now this was a really small number, which means that is in the place values that are negative powers of 10. So that's 10 to the negative 5. So 3.8 times 10 to the negative 5 is the scientific notation equivalent for that number. So today's purpose actually should be kind of short and simple for us, is to do operations with our numbers in scientific notation. If you remember, when we add or subtract, first of all, we must have the same name. In fractions, that was the common denominator. In whole numbers, that was lining up the place values. Decimals, that was lining up the decimal points. In other words, lining up the place values. In a scientific notation number, like 4.8 times 10 to the 7th, the part of that that signifies a place value or a name is the power of 10. That 10 to the 7th is actually the 10 millions place. So then once we have that same name, we combine the counts, and we keep the same name. So let's take a peek at some examples here. So let's do 4.8 times 10 to the 13th. Now those parentheses in this case are not an enclosing symbol. They're not saying to do anything there first. Here, they're just telling us that that is a single number. Plus 2.3 times 10 to the 13th. Well, note these are both 10 to the 13th, so they have the same name, which means we're okay to add them. Combining the counts, that means we're going to combine the 4.8 plus the 2.3 to 7.1. And then we keep the same name, 10 to the 13th. So 7.1 times 10 to the 13th is our result. Doesn't always stay quite that simple. We might have 6.3 times 10 to the 17th plus 8.1 times 10 to the 17th. Now here again, we have the same name. Both of these are 10 to the 17th. So we're going to go ahead and combine counts. 6.3 plus 8.1 is 14.4. Then we keep the same name, 10 to the 17th, so times 10 to the 17th. But there's a small problem with this. Right now, we have two digits, the 1 and the 4, in front of our decimal point. To be valid scientific notation, we can only have one digit in front of the decimal point. So we have to move this decimal point over to here, so it'll become 1.44. However, remember before, whenever we moved the decimal point, it changed the power of 10. So we made the number here smaller. This went from 14 down to 1.4. If the number gets smaller, the power of 10 gets larger. So 17 plus 1 is 18. So that's times 10 to the 18th. We have to be very careful when we get into our negative powers. We might have 5.9 times 10 to the negative 12th plus 4.7 times 10 to the negative 12th. Well, again, we have the same power of 10. Both are 10 to the negative 12th. So we're good to go there. We combine our counts. 5.9 plus 4.7 is 10.6. And we keep the same name. So times 10 to the negative 12th. Now, once again, we have two digits in front of the decimal point. One of them 0, but it doesn't matter. The first digit is not 0. So we have to move our decimal point again. We're going to move it over like this. Make that 1.06. Now again, the number changed. We moved the decimal point, so we have to adjust the power of 10. The number got smaller. It went from 10 down to 1. So the power gets larger. Negative 12 plus 1 is negative 11. That's 1.06 times 10 to the negative 11. What if we don't have the same power of 10? We have something like 7.38 times 10 to the 9th plus 9.3 times 10 to the 8th. We don't have the same power of 10 here. They're different. Now, if they're too different, we really can't combine the numbers. You know, if it's more than 3 or 4 apart, it's not worth combining the numbers because there's too big of a difference. But if they're only 1 or 2 different on our powers of 10s, we can adjust them to make it work. Typically, we go to the larger power of 10, which is going to be the 10 to the 9th. So this is going to stay 7.38 times 10 to the 9th. This over here is going to change to be 10 to the 9th. Now, just like up here when we were moving our decimal point, we had to adjust the power. Down here it's the opposite. When we adjust the power, we have to move the decimal point. The power got larger. It went from 8 up to 9. So this number here gets smaller by moving the decimal point one spot. That's 0.93 times 10 to the 9th. Now we have the same names, so we're going to go ahead and add. 7.38 plus 0.93, 8.31. And we keep the same name, times 10 to the 9. Any questions there?
What if they're like two vastly different numbers then? What happens then?
So like 4.9 times 10 to the 21st plus 9.7 times 10 to the 11th.
Yeah, something like that.
What happens there is, in reality, this number is so small that it's not worth even adding it to it. Because this is 10 to the 10th. It's actually 10 billion times larger. This number is 10 billion times larger than this one.
Yep.
It's really no point in combining them with addition at that point.
I was just trying to clear that up. I was just wondering about that. Or like,
that's a good question. It's just because of that's such a difference in size. It's like having, 250 million plus 2 cents.
I
The 2
was
cents
also
is
like,
so small compared to the 250 million, it doesn't really matter.
I was also like thinking like 1.65 times 10 to the, let's say 6 to the 8th power plus 6.3 plus 9 times the 5th power. You get what I'm trying to say, though.
They would always have 10 to the power because those are our place values because it's a base 10 number system. You could have other numbers, but it would be a different number base.
Okay.
Yeah, you wouldn't be able to work with them in operations if they have different number bases.
Okay, I was just...
Yeah, all the stuff we talked, if you look at the video from yesterday, all the stuff about combining these exponents, they have to have the same base. They have to be 10 to that power, or if it's a different number system, it would be 8 to the power or whatever.
Yeah, I was,
same base.
Like, again, sleep deprived yesterday, so I don't really remember most of it.
No problem, it happens.
Yeah, having your dog bark all night at another dog across the aisle from yours, and sleep stuff.
Whiskey puts the dogs out every time. I'm just
I do. For myself, I do Irish cream and melatonin.
Sure. We better look at some traction here quick.
Yeah, before we get sidetracked.
Just like with addition, we have to have the same power of 10. So these are both 10 to the 15. So we'll combine the counts. 7.8 minus 3.1 is 4.7. And we keep that same name, 10 to the 15th. Now, not always that simple. We might have something like 5.21 times 10 to the 18th minus 4.87 times 10 to the 18th. We have the same name. Both of these are 10 to the 18th, so we're good there. So let's combine the counts. 5.21 minus 4.87 is 0.34 times 10 to the 18th. We keep that same name. Now the issue here is the reverse of what we had before. Now we have no digits in front of the decimal point except for the 0. Remember, we have to have one non-zero digit in front of the decimal point. So this decimal point has to move that way to make it 3.4. Now in this case, the number got larger. It went from 0.3 up to 3. So the number gets larger, the power gets smaller. 18 minus 1 is 17. So that becomes 3.4 times 10 to the 17th. Now once again, we have to be very careful when we get in our negative powers. We have 8.13 times 10 to the negative 14th minus 7.71 times 10 to the negative 14th. Well, we have the same name, so we can go ahead and subtract here. 8.13 minus 7.71 is 0.42 times, we keep the same name, 10 to the negative 14th. However, once again, we only have a 0 in front of the decimal point. We have to have that one non-zero digit in front of the decimal point. So we move that over, it becomes 4.2 times, the number got larger. It went from 0.42 up to 4.2. The power gets smaller. So it's 14, negative 14 minus 1 is a negative 15. So that's 4.2 times 10 to the negative 15. Again, if we have different powers of 10, we'll adjust. We might have 3.27 times 10 to the 9th. Let's go something a little different. Let's go times 10 to the negative 11th minus 3.8 times 10 to the negative 12th. We go to we change them to the largest name, largest power of 10. Here, that's going to be the negative 11. Negative 11 is bigger than negative 12. So this will stay 3.27 times 10 to the negative 11. This one is going to change to 10 to the negative 11. Now the power got larger. Negative 12 plus 1 gave us negative 11. So the number has to get smaller by one decimal place. So we move that over. That's 0.38. That's 0.38 times 10 to the negative 11. And now we subtract. We combine counts. 3.27 minus 0.38. Oh, what is that? 2.89, I believe. Times.
Didn't you say the number got larger?
The number got smaller. It went from 3.8 to 0.38. So the power has to get larger. It went from negative 12 up to a negative 11.
Okay, my bad.
Confusing there. Negative 12 plus 1 does give you a negative 11. When we multiply or divide, remember we do not need the same name. So that means we are not going to have to worry about having that same power of 10 to multiply or divide. For number 2, second step, we're going to combine the counts. That's always our second step. And then the final step is we're going to also combine names. So let's take a peek at what that looks like. So we might have 2.1 times 10 to the 13th times 3.6 times 10 to the 21st. We have different powers of 10, but it doesn't matter because we are multiplying. When we multiply, we do not need the same name. So we're going to combine counts. 2.1 times 3.6 gives us 7.56. Then we also combine the names. So we have 10 to the 13th times 10 to the 21st. When we multiply exponents that have the same base, both of those have a base of 10, we add the powers. So 13 plus 21 is 34. That's 10 to the 34th. Be careful when we throw in negative powers again. We might have something like 6.4 times 10 to the negative 9th times 1.3 times 10 to the 14th. We still combine counts. We'll still do 6.4 times 1.3. Give us 8.32. Times, then we also combine the names. 10 to the negative 9th times 10 to the 14th They both have a base of 10, so when we're multiplying, we can add the powers. 10 to the negative 9th plus times 10 to the 14th, negative 9 plus 14 is 5. So that's 8.3 times 10 to the 5th. Doesn't stay that simple. We have 7.2 times 10 to the 15th times 3.9 times 10 to the negative 23rd. Again, we combine counts. 7.2 times 3.9. 8.08. Then we also combine the names. 10 to the 15th times 10 to the negative 23rd. Same base of 10, so we're going to add the powers. 15 plus negative 23 is negative 8. Now we're not done here. There's 2 decimal places and 2 digits in front of our decimal point. We have to move that over to make it 2.808. Now the number became smaller. It went from 28 down to 2.8. So the power has to get larger by 1. Negative 8 plus 1 is a negative 7. You have to be very careful with those negative numbers. Let's do another example of that. 9.3 times 10 to the negative 18th times 6.4 times 10 to the 9th. So again, we combine our counts. Get back here. 9.3 times 6.4. 59.52. Times, we combine our names. 10 to the negative 18th times 10 to the 9th. Again, we have the same base of 10, so we're going to add the powers. Negative 18 plus 9 is negative 9, so that's 10 to the negative 9th. We have to adjust the decimal place again. That's 59. We're going to move it so it's 5.952. The number got smaller. The power of 10 gets larger. Negative 9 plus 1 is negative 8. So 5.952 times 10 to the negative 8. When we divide, we just go in the back opposite direction. We might have 6.76 times 10 to the 18th divided by 1.3 times 10 to the 7th. We're going to combine the counts. 6.76 divided by 1.3, 5.2 times, we also divide the names. 10 to the 18th divided by 10 to the 7th. They have the same base. Both have a base of 10. So 18 minus 7 is 11. So that's 10 to the 11th. And that's our solution. We might have 5.76 times 10 to the negative 15th divided by 4.8 times 10 to the 9th. Well, again, we combine the counts. 5.76 divided by 4.8 is 1.2. Then we also combine the names. 10 to the negative 15th divided by 10 to the 9th. We subtract powers. Negative 15 minus 9 is a negative 24. This is times 10 to the negative 24th. We might have 3.24, 10 to the negative 8th divided by 3.6 times 10 to the negative 14th. Here we're going to divide our counts. 3.24 divided by 3.6 is actually 0.9. We divide our names. 10 to the negative 8th divided by 10 to the negative 14th. Well, we're going to subtract powers. Negative 8 minus a negative 14. Well, that remember is negative 8 plus a positive 14, which is a positive 6. So that's 10 to the 6th. Now, once again, we only have a 0 in front of our decimal point. We have to have one non-zero digit in front of the decimal point. So we have to move this over. That's going to become a 9. Now the number became larger. It went from 0.9 to 9. So the number gets larger, the power is smaller. So 6 minus 1 is 5. So that is just 9 times 10 to the 5th. If I take a number that's in scientific notation to a power, very similar to working with variables for those of you that had algebra, we're going to take the number to the power, so 1.2 to the power of 3. We'll punch that in our calculator. Could be 1.728, which it is. And then we also do the name to that power. Remember yesterday we discussed the power of a power? 10 to the 9th to the power of 3. We multiply the powers. 9 times 3 is 27. So that's 10 to the 27th. We might have 4.5 times 10 to the negative 11th, the power of 6. 4.5 to the power of 6. 8,303.77, we're going to call that. Times 10 to the power of, well, we do the negative 11 times 6 is a negative 66. Now here, the decimal point has to move several places. We have 4 digits in front of the decimal point. We're only allowed that 1. So we move it over 1, 2, 3 spots. That's 8.30377. The decimal point moved 3 spots. Our power also has to change by 3. The number became smaller. It went from 8,000 down to just 8. So the power gets larger by 3. So negative 66 plus 3 is a negative 63. These are ones that are best left up to practice. So we'll leave it to practice. In your book, or assignment is going to be page 130, exercise 2.6, 59 through 81, the odds. That's working with our scientific notation. Page 133, exercise 2.7, 1 through 23, the odds. This is working with that engineering notation that we brought up towards the end of class yesterday. So I'll let you guys have, we have about 19 minutes left here. Let you guys have that last 19 minutes to work if you like. I'll be here to answer questions. Otherwise, that is it for the